today we're going to start talking about surface area, or I should say continue with surface area, but now we're going to concentrate on just our pyramids and our cones. Remember that we've already done surface area of our prisms, and we talked about a couple different ways we can do that, like taking apart all the pieces of the prism into its individual flat shapes, like squares and rectangles and triangles, etc., and circles. And then we can find those separate areas and then add them all back together. I'm going to show you how to do that, the same thing with our pyramids and our cones, although cone, a little tricky to show you that one. I'll show you when we get there. But basically, we can do the exact same thing that we've already done. And remember, we also have a formula, though, to help us if you like to use the formula. But again, I'll start with taking it apart. Looking at this shape here, again, you're using this worksheet right here, 7-8. It says Study Guide and Intervention. It says Surface Area of Pyramids and Cones. This is the first example. This is example number 1 on your sheet. So that's what you're looking for right here. So we have a square pyramid. We can tell it's a square pyramid because our base is 4 by 4, and it's a square. So therefore, that is our square pyramid, and remember, it's always named for the base. So let's write that. We have square pyramid. Okay, so now what we need to do is I'm going to take apart this pyramid as if it was pieces that were kind of just laying together or stuck together. I'm going to take them apart. So I'm going to start with my base. The base we already said is a square, and I'm going to label it as 4 by 4. Well, we also know how to find the area of a square or a rectangle. We know that area equals length times width. That means that area equals 4 times 4 in this case. That means that area equals 16. Okay, so that's 16 feet for that. We also know that we have triangles. Now, each triangle, I could take it apart sort of like this. I should do it this way. I could take apart the pyramid by taking it apart from the tippy top. So taking it apart from here, and it would look sort of like this, with each of these triangles off of the square. Now, I didn't draw it well, but each one of those triangles are the same exact measurement because all the triangles have a base right here. The base is always going to be 4 because it's always on that square. So that part's pretty easy. Now, this here, this 5, I'm going to erase this so you can see it. But this 5 right here, this is referring to the height of the triangle. You can see it on a dotted line right here, and you can see we've got a little right angle here to the base right here. Okay? So that's what we're looking at. We're looking at that triangle there. I'll finish outlining it in green. So this triangle right here is what we're looking at to show that that height means the height of the triangle. So I'm going to draw the dotted line here, and this is 5 feet. Again, though, I have 4 of these triangles, so I need to do whatever this is, and I'm going to times it by 4 because I have 4 triangles. So again, area of a triangle, area equals half BH. So area equals half times the base is 4, and our height is 5. Half of 4, remember we can make it easier, that's 2. So area equals 10 feet squared. And remember, I need to times it by 4 because I have 4 different triangles, or add it up 4 times, however you like to do it. So this is going to be 40 feet squared. Now remember, this is just for my triangles, and then this was my area for my square. So I have to add those 2 up. So I have 40 plus 16 gives me a total of 56 feet squared. Okay? So that's, that's my surface area. That's what we're doing there. Surface area is 56 feet squared because I found each individual thing, and then I just went from there. Now there is a formula, as I was saying, so I am going to show you how to do it with the formula as well. The formula does get a little bit tricky, though. So if you look at your formula sheet, this surface area formula that they give you, they only give you a square or rectangular pyramid like this, and then they give you your cone. They don't give you anything else. Like the bottom, remember our base here, which was 4 by 4, which was our square. The base really could be anything. We already know it could be a circle for our cone, but it could also be a triangle. It could be a parallelogram. It could be anything. But this same surface area formula works for every base shape, or every, and no matter what the base is, as long as it's a pyramid, it works. So this is half of L, and it's a cursive L, or different, actually it's a different kind of cursive L, actually, excuse me. It looks like this. It's kind of like that kind of an L. And this is L and P plus capital B. All right, we have to remember what these things stand for. This is a new thing we're talking about here. This weird L, which is a little different than the L I've been drawing before. This L stands for slant height. And slant height is exactly what it sounds like. If we were going to kind of lean away from a wall and sort of make almost like a, like I said, with our head touching the wall but our feet away from the wall, we would be this line right here, because it's the slant part of the pyramid that you're looking at. It could be the pyramid, could be the cone, whatever we're looking at. This P here is the perimeter of the base. You have to remember that. It's the P of the base. So whatever the base shape is, in this case, for example 1, it's it's a square. So it's the perimeter of the base. Remember that this capital B here is referring to the area of the base, and we've talked about that before. Area of the base times the height. In this case, again, it's the square, but it's the area of the base. And again, whatever our base is, that's what we're doing for the capital B there. All right, so let's fill in a few things. That means I have half. The slant height is 5. So half times 5, because this is my slant height that I'm pointing to right here. That's the slant height of the pyramid. Times the perimeter. The perimeter is all the way around the bottom, so it's 4 plus 4, and then there's a 4 and a 4 on the back too. So when I add all those up, actually I'm going to do it like this: 4 plus 4 plus 4 plus 4, because that's my perimeter, because I'm adding all the sides. We know sum of all sides is perimeter. Plus the area of the base, well, the base we just said is length times width, so that's going to be 4 times 4. And I'm adding that up together too. When I do all that math here, what I wind up with is all of this becomes 40, and this is 16, which means that my surface area for that square pyramid is going to wind up being 56 feet squared. And we already said that. You can see it's the same kind of, the same idea, just a little using the formula instead of breaking it down into all of its parts. So however you like to do it is fine. If you want to do both ways as you're taking a test or anything like that to check, that's a good idea. But obviously for homework or something, pick which one you're comfortable with and make sure, as long as you're getting the right answer, you're doing great. So whatever one you're comfortable with. This formula does get a little tricky because you have to have a lot more things to remember with things like the slant height, the perimeter of the base, and then area of the base. So do be careful with that. All right, the next one we have is a cone. With our cone, it gets a little tricky. We really have to start with the formula almost from the get-go. But I'm going to show you again how to break it apart. At the bottom of my cone, I have a circle. So what I'm going to do here is I'm going to draw the circle. And I know I need to find the area of the base. We've talked about that. So the area of the base is, the radius is going to be 3. It's telling me right here. Radius is 3. That means my D is going to be 6. If I went all the way across, because if that's 3, then all the way across would be 6. Remember, I just like to write them both down just to make sure we're ready for either one. So I'm going to find the area of the circle. Area equals pi r squared. We already know that. So 3.14. The radius is this one. So we're going to do 3 times 3. And when we do our math, the area becomes 28.26. This is meters squared. Now, it's hard to do the lateral side part, which is this part, the cone part, so to speak, right? Because if I were to take that off and cut it, it actually winds up looking a little bit like a Pac-Man. If you remember that game, it kind of would look a little bit like this. This is the top of my circle. That would be when I fold this, I'm going to draw it here. When I fold this part in together with this part and touch them, it would make that cone shape. And then I would have the circumference would be from here all the way around to here. okay, is what we're doing there. So this part of it, we really need to remember what the formula part is, because there's no way to find that area with that piece missing. So I have to remember that this part, the formula for this area equals pi r L. And again, it's that kind of fancy L. And you'll see it different ways, but it doesn't mean length. It means slant height. Again, this is where it gets a little tricky. All right, so we have 3.14. Again, the radius is still 3. We go right back here. The radius is still 3. And my slant height now, remember, it's right here. This is showing me this height right here that slants in. That's my slant height. So then I'm going to times it by 5. When I do that math, I wind up with 47.1 meters squared. So again, this part I think we can remember. That's not too hard. But this part gets a little tricky. We do have to kind of memorize that part, or at least be able to recognize it on our formula sheet. So now that I've done that, I have my circle and I have my leftover part, we'll say the lateral side part, and I need to add them together. So I have this and I have this, and I'm adding them together. So 28.26 plus 47.1, and when I add them up, I wind up with 75.36 meters squared. And again, that's my surface area. That's all I'm finding there. Okay? Let's do another one. This one is the triangular pyramid. And we don't have a formula listed on our paper because we have to remember that that square pyramid or rectangular pyramid, that formula for surface area works for all of them. But it also, now this one is going to show you a little bit different. The base is a triangle, and it's actually an equilateral triangle. They're all the same. We have 6 by 6 by 6. This is drawing a line right there to that back side. So this triangle that's on the bottom, that's an equilateral triangle of 6 by 6 by 6. We also are already given the area. There's the area. So I actually have no work to do there. I'm good to go. So my base, the area of the base is already done, 15.6. Phew. Okay, that was a lot of work, right? Okay, so that part's done. Now I have 3 more triangles. That's the lateral sides that are making up the point as they meet up here. So again, let me draw it out for you. If this is the base, right here, I have 3 more triangles that I unfolded from here. I unfolded them, and so this is one of them, this is the other one of them, and then this is the other one of them. And I'm sorry, I'm not drawing this very well. That wasn't a very good drawing there. But that's, let me do this again. I'm trying to make it so it looks more like what it looks like. Okay, so hopefully a little bit, maybe that's a little bit better. But that's what I'm looking at here. So this, I have these triangles. They're now all the exact same size and shape because, again, we already know that our base right here, that's 6 on all of them. So there, that's 6 and that's 6. Now we need to know the height. But the height is the same on all of them because the height is the same as the slant height. So that is 8.9. All right, so area equals half BH. But remember, I have 3 triangles this time, so I'm going to times it by 3 when I'm all done. That means I have half times the base, which is right here. That's 6, we already said. And the height, we said, is 8.9, which is the same as the slant height. So again, that kind of can be confusing too, because not only is it the height of the triangle, that's that lateral triangle, but it's also the slant height of the pyramid. So it kind of has a double duty. All right, so half of 6 is 3, and then I'm going to do 3 times 8.9. And I get 26.7 and centimeters squared. But remember, again, I said I have 3 of them, so I need to times this by 3. So when I do that math, I wind up with 80.1 centimeters squared. But remember, I've got the base already. I need to add the base to that. So I have base, and I have all my lateral sides together, so I'm going to add them up. So when I add these 2 things up, I wind up with 95.7 centimeters squared. This is my surface area of the entire thing. Okay? So that's the surface area when I have a triangle base. But again, doesn't matter what the base is. This one I highlighted in green. Now I'm going over it in red. That base was a triangle. It could have been a square. It could have been a circle. It could have been a, well, maybe not a circle because, again, we have that other formula. But it could have been a trapezoid, a parallelogram. It could be a lot of different things. So you need to kind of watch what that base might be. It could be a pentagon, hexagon. As long as they give you the area of that, we can do the rest of it, because the rest of it's always going to be triangles meeting up to the top, unless it's a cone. Then we talked about that. All right, sometimes they're going to give you it in words. So it clearly tells me I have a cone. This is number 15, by the way, obviously, on your sheet. This is a cone. All right, let me draw a cone so I can see what I'm talking about. A picture, a lot of times, is going to be way more helpful than just trying to go with the words, okay? So there's my cone. It has a diameter of 26 inches. So the circle part going all the way across, diameter is 26. That makes the radius 13. Remember, we always want to think about that too. The slant height, remember the slant height now is this part right here that's going from here to here. That's the slant height, and it's telling me that it's 8. And by the way, this is inches, what we're doing here with this. Okay, so let's work it out. I'm trying to find the surface area. I know I need the base first. So the surface area is equal to pi r squared for the base. So that's going to be 3.14 times the radius, which is 13, times 13 again, because it's squared. If you want to put 13 squared, that's okay. When I do that math, I wind up with 530.66 inches squared. Okay, so this is the surface area of the circle part, right? So that's what we have here. I still need to do that lateral side part. So remember, it's that Pac-Man kind of shape. So remember that formula part is pi r L. And I've seen it. This is kind of how they're doing the L on your paper. Okay? So pi r L. So again, we have 3.14, don't forget my decimal, times the radius, times the slant height. Remember, this L is referring to the slant height. When I do that math, I wind up with 326.56 inches squared. And again, that's my surface area of the sort of the Pac-Man shape that I showed you before. Again, when I add these together, these two need to be added. I need to add them together. I wind up with 857.22 inches squared. That's my total surface area of the cone. But remember, if they give it to you in words, it's a good idea to draw a picture. Okay, make sure if you have any questions, now would be the time to ask them, and I will, or write them down, and we can get to those questions that you have.